Uh, Excuse me, sir. Sir, I guess you're on mute, sir, because we couldn't hear
Oh,
anything.
I'm sorry. I forgot to unmute anyway. So I've just given you one example which will recall everything that we have done in the previous lecture. So the first one was the dot product of the two vectors a bar b bar. The second one is the modulus of c bar. So Nishu Singh, Shivraj Deshmukh.
Yes, sir. Nishu Singh.
Yes, can you tell me modulus of c bar?
Excuse me.
Okay, anyone else?
Hello, sir. One.
Yes, Tarun.
Uh, One, sir. Answer is one.
How come it is one?
Sir,
Under root
one
I
square
square plus j
under
square.
root one
One square.
plus one square minus one.
So it is under root 3.
Oh, so sorry. Sir, yes, sir. Under root three.
Third. What is a cap? A cap is actually the unit vector in direction of A. So it is defined as A bar upon modulus of A bar. So this is equal to 2i plus 2j plus 2k plus k. Upon under root 2 square plus 2 square plus 1 square. So it is 4 plus 4 8 plus 1 9. So that will be 2 by 3 I cap plus 2 by 3 j cap plus 1 upon 3 k cap. So this is your E cap. Fourth one, A bar cross B bar. How do we find A bar cross B bar? Ganesh, Desai.
Yes, sir.
Yes, how do we find out A bar cross B bar?
Future, I was absent previous lecture, so I don't know.
हाँ
Sir, mod of I cap.
Mod of? Yes, it is determinant.
Sorry, sir. Determinant.
Ijk.
X1, Y1, Z1.
So that is 2, 2, 1, 1, minus 1, 2. So we find out the determinant of this I in bracket this into this. So 4 minus of minus 1 minus j 4 minus 1 plus k minus 2 minus 2. So it is 5y minus 3j minus 4k. This is A bar cross B bar. Fifth one, A bar cross B bar dot C bar.
Determine X1, Y1, Z1,
So
X1,
2,
Z2.
2, 1, 1, minus 1, 2, 1,
1,
1,
1, minus 1.
minus 1. So the answer is I'll Yes, what is the answer?
6.
6. And the last one, sixth one, angle between A bar and B bar. So what we know is cos of theta is equal to A bar dot B bar upon modulus of A bar modulus of B bar. And so A bar dot B bar is, we have found out what is the answer. Yes, 2
2.
upon modulus of A bar, which is 4 plus 1, 9, which is 3, and 1 is 1, 6 root 6. So theta is the angle between the two things, then theta is equal to cos inverse of 2 upon 3 root 6. Okay, so this is all we have seen in the previous lecture. So now we need to start with vector differentiation.
सर वो cos इनवर्स ऑफ 2/3 √6 उतना ही किया तो छोड़ उधर ही छोड़ दिया तो चलेगा ना?
Yes, yes. So if r bar is equal to x I cap y j cap plus z k cap, the vector, then d r bar by dt is equal to dx by dt I cap plus dy by dt j cap plus dz by dt k cap. So in this case, dr bar by dt represents the tangent vector. Tangent vector. First one, tangent vector to this r bar. Okay. Second one, dr bar by dt represents the velocity. Represents velocity vector, is also denoted by v bar. And third one, so d2 r by dt square, r bar by dt square represents acceleration, which is also dv bar by dt. Okay, so v bar is the velocity, so derivative of velocity, which is acceleration, that we already know. So it is d2 r bar by dt square. Okay, all the rules of derivatives that you have seen in your previous class, all of them are same. So the way you took the derivative over there, the same rules are going to be applicable here. So I'll just, there are new products, say cross product, dot product. So we'll see what happens when you take the derivative of cross product and the dot products. So d by dt u bar plus v bar will be equal to du bar by dt bar plus minus, I'll combine both the properties, dv bar by dt. So if we have d by dt of dot product u bar dot v bar, then this is equal to v bar dot du bar by dt plus u bar dot dv bar by dt. So till this there is not much difference, everything will be same, but the problem arises when you have the cross product. So d by dt of u bar cross v bar, so it will be du bar by dt cross v bar plus u bar cross dv bar by dt. So order should be maintained because we know that u bar cross v bar is not equal to v bar cross u bar. Okay, cross product maintains the order. So whatever is the order, that order should be maintained. If it is not, then answer will be wrong. So that's why when you are taking derivative of cross product, this order should be maintained. First of all, take the derivative of u at its place, I mean u, and when you're taking the derivative of v, it has to be at the second position, u bar cross dv bar by dt. Okay, so don't forget to maintain the order in which the product is given. So next property, d by dt of u bar cross v bar dot w bar. So this is the box product of three vectors. I'm taking the derivative of it. Again, order very important. Du bar by dt cross v bar dot w bar plus u bar cross dv bar by dt dot w bar plus u bar cross v bar dot dw bar by dt. Next one, d by dt of s into u bar, where s is a function of t, where S is function of t. So now here you can see that S can be treated as a scalar in this case. Scalar, I mean to say, it is not a vector, it is a scalar quantity, and this is a vector. But still, since it is a function of t and vector is also the function of t, we'll have to apply the product rule du bar by dt plus u bar into ds by dt. So d by dt of u bar upon s is equal to s into du bar by dt minus u bar into ds by dt upon s square. Okay, so that's all about the derivatives. Please remember that tangent, what is tangent, what is velocity, what is acceleration. So if there is an objective question on this type, so that you will be able to do it.
Sir, uh,
Yes.
the tangent and the velocity are represented as dr bar by dt. So how do we differentiate that?
You'll see, we're going to solve some examples. You'll understand how do you differentiate.
Okay.
So example, a curve is given by x is equal to t square plus 1, y is equal to 4t minus 3, z is equal to 2t square minus 6t. Find the tangents at t is equal to 1 and t is equal to 2. So first of all, we have the curve which is given by this. So r bar is equal to x I plus y j plus z k. Okay, so x is nothing but t square plus 1 I means y is 4t minus 3 j plus 2t square minus 6t k. This is your r bar. Now we know that the tangent is nothing but dr bar by dt. So I want to differentiate this with respect to t. We know that the derivative separates over addition. So that will be d by dt of t square plus 1 I bar plus d by dt for t minus 3 j plus d by dt 2t square minus 6t k. So the derivative is 2t I plus 4j plus 4t minus 6k. This is your dr bar by dt. So Dhruv, I hope it is clear now how to take the derivatives. right?
Yes.
It is just that you have to separate the derivative over addition and subtraction. Now I need tangent at t is equal to 1 and t is equal to 2. So if I want a proper tangent, I should put the values. So dr bar by dt at t is equal to 1. So we'll get the first tangent, that is 2I plus 4j minus 2k. This is tangent at t is equal to 1. Tangent at t is equal to 1. Now dr bar by dt at t is equal to 2. So that is 4I plus 4j plus 2k. This is the tangent at t is equal to 2. Okay, next example. For the curve x is equal to e to the power t cos of t, y is equal to e to the power t sin t, and z is equal to e to the power t. Find the velocity and acceleration of the particle moving on the curve at t is equal to 0. So what is our r bar? Is equal to x I plus y j plus z k. So you can put the value of x e to the power t cos t I plus e to the power t sin t j plus e to the power t k. So the velocity will be derivative of this. So differentiating with respect to t. So we'll get velocity vector dr bar by dt. So d by dt of e to the power t cos t I plus d by dt of e to the power t sin t j plus d by dt of e to the power t k. So the derivative of e to the power t cos t, use the product rule, e to the power t derivative of cos t is minus sin t plus e to the power t cos t I plus in bracket e to the power t cos t plus e to the power t sin t j plus e to the power t k. This is the velocity vector, which can be simplified as e to the power t in bracket cos t minus sin t I plus e to the power t outside cos t plus sin t j minus e to the power t k. So we don't need velocity everywhere. We just need the velocity at t is equal to 0. So velocity at t is equal to 0 will be cos 0 is 1, sin 0 is 0. So this will be I 1 plus j minus k. So this is the velocity vector at t is equal to 0. We also need the acceleration. So differentiating velocity once again with respect to t.
So it's
So
k plus k, right?
Sir, it is
how
plus e to the power t plus k plus.
plus plus k bar. Yes, thank you. Now differentiating this velocity once again. Differentiating v bar with respect to t. So you'll get the acceleration vector a bar dv bar by dt. So this is equal to d by dt e to the power t cos t minus sin t I plus d by dt in bracket e to the power t cos t plus sin t j plus d by dt e to the power t k. So let's use the product rule two times now. So e to the power t as it is in bracket, derivative of this will be minus sin t minus cos t. Minus sin t minus cos t plus cos t minus sin t e to the power t. This is the product rule for the first one, I. Please check the calculations plus e to the power t as it is in bracket derivative of this cos t plus sin t, that will be minus sin t plus cos t plus cos t plus sin t e to the power t. This is the coefficient for j plus derivative of e to the power t is e to the power t k. We need acceleration at t is equal to 0. So let's put the value t is equal to 0. So acceleration at t is equal to 0. In the first bracket, e raised to 0, sine 0. So what we have? Minus 1. This is cos t minus sin t, that will be plus 1. I plus in the other bracket, sin 0 is 0, e to the power 0, 1. In the second one, cos 0, 1, e to the power 0, 1. 1 plus 1, j. And the third one, k bar. So this two will get cancelled out. So acceleration at t is equal to 0 is equal to 2j plus k. Any problem?
No, sir.
Third example. A particle a particle moves along a curve x is equal to 2t square, y is equal to t square minus 4t, z is equal to 2t minus 5. Find the components of velocity and acceleration at t is equal to 1 in. Okay, let's cut down this velocity. Find the acceleration. Find the component of velocity at t is equal to 1 in direction of I minus 3j plus 2k. First of all, we'll see how to find out in direction of this vector, but I need answer from you. What is the velocity at t is equal to 1? Please do it quickly within 5 minutes.
So 4 I bar minus 2j bar plus 2k bar
4 I bar
minus 2j bar plus 2k bar.
This is Shaunak. Okay. So velocity at t is equal to 1 is this. Now you have seen this in your other subjects. So you have some force. Okay. You have a pendulum like this. And then you have a force acting on this. This is the tension which is acting in this direction. And then you resolve this. How do you resolve this tension? There will be some force acting in upward direction and some force acting in this direction. So you say t cos theta, t sin theta, something like that. Okay, so t cos theta, t sin theta. So this vector has some component in this direction as well as this direction. That is what is called resolving. Okay, in the similar manner, when I say this vector, this may be somewhere like this 4 minus 2, it is like this, and I minus 3j plus 2k is this. So this will have some component in this direction. That is what we need to calculate. And how do we calculate this? I'll just give you a small remark. So you write it down in the list where you are writing down all the formulas. A remark. Component of a vector A bar in direction of B bar is given by A bar dot B cap. What is B cap? What is B cap? Anyone? What is B cap?
Unit vector.
Unit vector in direction of B. So B bar B cap will be equal to B cap will be given by B bar upon modulus of B bar. So that is A bar dot B bar upon modulus of B bar. So this is how you get the component of one vector in direction of other. So we have the velocity now. I need the component of velocity in direction of this vector. So I'll name this A bar is equal to I minus 3j plus 2k. So modulus of A bar is equal to under root 1 square plus minus 3 square plus 2 square. So this is under root 1 9 4 13 and 1 14. So component of V bar in direction of A bar is V bar dot E cap, which is 4i minus 2j plus 2k dot I minus 3j plus 2k upon under root 14. So we can take the dot product of this. While taking dot product, we mean that multiply the coefficient of I to I, j to j and k to k and add them. Plus 6 plus 4 divided by under root 14. 6 and 8, 14. 14 upon root 14 is root 14. This is the component of velocity in direction of that vector. Okay. Fine. We will stop here. In tomorrow's lecture, we'll see gradient, divergence, and curl. Now, tomorrow we also have a tutorial. So that tutorial will be conducted online, and that will be theory tutorial this time. So everyone, be prepared to solve set of 5 questions in 1 hour, and I'll strictly monitor this time. And after 1 hour, I'll be checking those tutorials, and you will have to submit on the classroom like you have been doing till now. Any problems?
No, sir.
No, sir.
Yeah. Thank you, everyone.
Sir, the tutorial on Laplace is remaining, no?
Yes, the same tutorial I'll be conducting tomorrow.
Okay, sir.
Yeah.